All right?
We're on.
All right, so welcome to this presentation. We're going to talk today about some mythical thing, which is the Graal, and how it can interact with Tomcat and your web apps. Because, as I'm going to show, Graal wasn't made for things like J2EE or webapp or anything like that. So we're going to see how we can put that all together and get to something that actually does something. Alright, so I'm Rémi Mochera, I'm a software engineer at Red Hat. I've been a long time Tomcat contributor. Alright, so the contents are, first we're going to talk about how Graal works and its general principles. We're going to describe the problems and hopefully some solutions to the things you'll encounter. To show how it works, basically we're going to work with examples web apps from Tomcat, and we're going to show the process of making it work compiled into a native image. Last, we'll talk about putting that all into a container and see how it runs. Okay, so the general principles. Graal was a project developed by Oracle. It didn't start as a JVM made to compile into native binaries or whatever. It started as a project to develop a new just-in-time compiler for Hotspot. In the end, it ended up being a multi-language JVM, so it supports a lot of languages besides Java. We don't really care about that here, but it does it. And most importantly here, that's the thing everyone's interested about. I was compiling Java software into native executables. So you have the URL of the project in case you don't know it. Okay, so it has two main components basically. The first one is a substrate VM. It's called substrate because that's the thing running underneath the native image in theory. In practice, the goal is to get a standard native image. So the substrate VM at the moment, basically it's just a regular JVM. It runs Tomcat 9 just fine out of the box. I had nothing to do to make it run on the substrate JVM, and I said, woo, Tomcat 9 is Graal compatible, woohoo, I'm all done. No, but actually that wasn't the case at all. That failed horribly after that. But it gives you a very wrong impression the first time, like it runs, just works. That's excellent. Okay, one problem though, one immediate problem is that it works as a Java 8 JVM, doesn't support Java 11. It's coming soon, which means it's going to be taking some time. And it supports other languages, plenty of them actually, including C and all sorts of kind of stuff. Okay, so that substrate VM, most importantly, is then used for the native image creation. Basically, the native image is just a tool that uses the substrate JVM. Okay, so the native image itself, it's a very early access technology that allows, as I said, compiling to native executable. And ultimately, if you do it right, it's self-contained. If you do it wrong, it's going to say, oh, I'm going to write to generate a native image that uses the substrate JVM, and basically it tells you failed because it won't do anything useful at this point. Okay, so if you do it right and you generate a real native image, it has a very, very fast startup, like instant, and very low memory use on startup at least. And I mean very low. I'm going to show how low. That's very impressive. Okay, so immediately after you start, basically besides running the substrate JVM with your program, you're going to run into problems. So we'll also look into solutions because solutions are good. Okay, so how we'll do is that we'll do a demo, basically, as I said, based on the Tomcat examples. Tomcat examples have all sorts of basic stuff from the servlet spec and the companion specs. And it's very diverse and shows a lot of stuff. So basically it has servlets, JSPs, expression language use, WebSockets. We can test it with Tomcat Native and OpenSSL. So that's a lot of stuff to demonstrate. We'll do a step-by-step demo along the way, because it's a multi-step process, as you'll see. At the end, if I don't scrub the demo, we'll have a native image with all the Tomcat examples. Most of the Tomcat examples. There are still some which still don't work, and I'll show you how and why. I'll put the wiki page isn't up there, but I'll put the wiki page with a demo script, so you don't need to take pictures all the time, because there are some huge command lines and all that kind of stuff. So if you try to take notes of that, it would be hard. There's a video being made also, so you'll be able to find out everything later on. So limitations. Immediately after you try to do something with the native image creation, you'll notice when you do a native image generation, it will work from a single jar. It will build a native image binary out of a single jar. You can use shared libraries to some extent, but it's a lot more complex. So basically, you want to work with a single big jar. Also, since in the native image, one immediate limitation is that you don't get dynamic class loading, which means if you try to do something which uses normally dynamic class loading, like class for name, it won't work. You have to declare it ahead of time. So think about it. All right. So you need to declare it. And also, you have parts of Java which aren't implemented. Which parts of Java aren't implemented is that usually the ones which are pretty reflection heavy. Like, for example, JMX, it's not implemented at all. You don't get JMX support. If your program uses JMX, Graal native image will kindly say, when you try to do something JMX related in your code, oh, I can't generate a true native image out of it, I'll use a substrate JVM instead, and then you fail, basically. So it's like that for a lot of technologies. Some items in some some core Java specifications aren't implemented. For example, JNDI has limitations. What else? Java util logging was recently implemented, like 6 months ago it wasn't implemented at all. But now it's implemented, but it also has some limitations. Doesn't behave exactly like a normal one. Yesterday I was asked about Java method handles, which is a fast reflection API, and it's not implemented at the moment, so you can't use that basically. Overall, Oracle says it's a technical preview, and that's really what it is at the moment. Okay, so there's a configuration process for all the reflection that goes on in your program and that you want to have work in a native image. You have to use descriptors for that. They are very verbose. We have a packaging from Tomcat that I'm going to use for that process. I'm going to show it just a bit later. So Tomcat Maven provides base descriptors for Graal and also native interface, the base interfaces and the resource bundles that Tomcat has. So they give you a base to run Tomcat in a native image. Okay, so the general idea is that to generate these descriptors, you would run the Graal substrate VM with a specific user agent of that JVM. Basically, the agent, which is provided by Graal, will intercept reflection calls and class loader access, and will generate the needed descriptors from that. So the general idea is that you start Graal with that agent, then you you exercise your web app. It will at the end generate the trace configuration with the trace descriptors. And then you have to verify everything was correctly generated, because that's not always the case in some cases. So what I found is that Tomcat standalone, it has a lot of jars, and it would be too difficult to move directly over to Graal, because we would have to use single shared libraries and have them work together, and to regenerate each individual library, it would be too difficult. Also, another problem, basically web apps, due to the way the native image work, everything has to be compiled into the native image. So if you have classes in your web app, in webinnflib or webbin classes, they're not going to be compiled into your native image because it will only compile what is in the main jar. So although Graal will know about those classes, it won't be able to load them. You have to compile them ahead of time. There's absolutely no problem, however, for configuration files of Tomcat, like server.xml, we work just fine, logging, access logging, solving static files, that's not a problem. Any real true file access is not a problem generally. It's only class loading which is a problem. Also, if you have multiple web apps, no problem. So static files, multiple hosts, no problem. TLS in most configuration is okay. In the end, there are some very big problems with TLS, but not exactly for very intuitive reasons. It's just the way the native image is compiled, which is in the end causing problem for TLS, but in theory, like in the base config, it's not causing problems. So I had to do a lot of fixes in Tomcat to make things work. First one is disable JMX, because no JMX, so I have to get rid of that immediately. I had to simplify the JSP runtime library. It's using a lot of reflection based on bininfo. Bininfo is a bit a problem in Graal since it's not traced, so you would have to basically write the descriptors manually. That's kind of a pain. So I wrote a simpler JSP runtime library for use bin and kind of like things like that, you know, set properties and whatever. I wrote something with straight reflection and that worked a lot better. Also, as I said, the GNDI implementation is a bit lacking, and the reference resolution with the normal code isn't kind of not working. So I wrote the reference resolution with straight reflection again. Probably not 100% compliant, but it works for what we do in Tomcat. As I'll show, some listeners from the default server.xml are not compatible, but it's kinda obvious which one aren't going to be compatible. For example, we have, you know, a GRE leak listener. So it's not a GRE, it's a native image. You probably don't care about memory leaks the way you do with a normal Tomcat where you would reload web apps and do stuff like that. So you can get rid of that immediately because it's using like internal reflection on some objects that don't even exist in Graal. So that's why it fails. You have another listener about JMX, so it's also not compatible for obvious reasons. And so the goal is to provide also base JSON descriptors for the native image generation. Basically, as I said, the trace agent isn't detecting like some base interfaces that are used in reflection. And so you have to, basically I had to provide a base descriptor which said like, you have org Apache Catalina context, it has to be known to reflection and things like that. And also base interfaces of Catalina have to be provided, also the resource bundles, because they are class loader resources actually, you know, your resource bundles, they are loaded to get resource as stream, and yeah, that's stuff that needs to be compiled into the native image. It's not a regular file anymore. Alright, so to achieve all that, I worked on a packaging I created for containers. I called it Tomcat Mavens, probably bad name, but yeah, it was an example to create container images from Tomcat, basically, and it produces a fat jar with all sorts of stuff from Tomcat, a bit whatever you need. Basically, you write in your POM like the dependencies you want on the Tomcat jars. Like if you want clustering, you add a dependency on clustering. It will add the clustering classes in the fat jar. And also it can package the web apps. Now that's very interesting because I needed for my Graal stuff a fat jar with everything including web app classes, so that's pretty handy here. Other than that, it's very similar in use to Tomcat standalone. It can use a server.xml, web.xml, The web apps are normal looking. It will do normal logging. It can use Tomcat native for TLS or whatever. So everything's good. So that was a good starting point to play with a native image, basically. Okay, so as you see, your web app, although it will stay the same, it has to be packaged in a specific way. So I added tools and things to do the packaging. So there's a packaging script in Tomcat Maven. It allows you to precompile JSPs because since you don't get any dynamic class loading, obviously you don't get, well, you could get source code generation, no problem, but you won't be able to compile and load dynamically JSP. That's not possible. So you have to compile them ahead of time. So thankfully we had the JSP precompiler. The first step is to precompile the JSPs. The JSP precompiler, which is the JSPC, will generate web.xml, basically with all the JSP servlets which are generated, and will map them into your web app. So it's still fully transparent. Basically, it's not making any real changes to your application. So the last step of the process is to copy all the servlet source and properties that were generated, including the regular servlets actually, to a source main, where it will be packaged inside the main jar. You also need to add all the library dependencies to the POM, so that also they get into your fat jar. And then you can use Maven to build the fat jar with Tomcat and all your web app classes. I'm going to show you how exactly. So the process first, using Tomcat Maven. So I'm going to show what it looks like. Okay, so Tomcat Maven, here we have a lot of stuff. So we have Docker files. Docker files, that's for generating the container image at the end. So we have that Graal web app whatever, and that's the web app compiler, the web app packaging. So basically, all it does is define your JSPC task, nothing special. Basically, it creates the paths for Maven. It does JSP precompilations and copies the result into main Java and then the properties file into main resources. So nothing very fancy here. So we have the main POM. If you are interested to look at it, it's pretty simple. Just list a lot of dependencies from Tomcat. And all the stuff from Tomcat you want to put there, like for example, if you want WebSocket support, you add that. So there's Maven names of the main Tomcat jars. It's not the embedded stuff actually. And so you use the compiler plugin and the shade plugin. So nothing very fancy also, there's no magic here. Okay, you get a README file with instructions. That's very useful, but since I'm working you through them, you don't need to read it at this point. I got a few playbooks also to deploy the container image into, like, for example, OpenShift or whatever. So there's one for the regular packaging and one for Graal. Okay, so there's the descriptors for Graal. Those are the base one, basically. So Tomcat Reflection, for example, as you can see, it has all the base interface names from Tomcat because they are not detected out of the box, basically, so I needed to list them manually. So for example, here you have the base realm interface. Otherwise, reflection will, class loading will fail. So we also have some stuff like at the end for JAXP and the expression language and some JNDI stuff and also a bit of WebSockets. So you need that base file, otherwise your compilation, your native image process won't work because those things aren't fast for whatever reason. Okay, in the resource file, it's a bit the same, except it's about resource bundles. Unfortunately, there's no resource bundle tracing at the moment in Graal, so you have to do it manually for all your resource bundles. So every package, you have your package with your local strings, whatever. That's how it works in Tomcat. So you have a lot of them. You also have some resources which are loaded using sometimes get resources as strings to be really careful. I included everything from the Tomcat sources, like all the DTDs and stuff. It works well like this. So, all right, let's go back. All right, so using Tomcat Maven. So what's there? I already talked about it. So the structure we have from there is very similar to Tomcat standalone. You can use the same folders. Like for example, the default library path for Tomcat native is the bin folder now. So basically, I'll put my Tomcat native in the bin folder. The conf folder is just the regular configuration files. So I'll have server.xml, web.xml, my key store, my login config, whatever. Source mail, that's for Maven, that's for the compilation. So I have the additional Java sources and resources from the web apps that I want to compile into my jar. Web apps, I'll have my web apps. Work will be the Tomcat work folder when we run it. Alright, so we are going to start the packaging now. So, first, okay, I have a script to avoid forgetting anything. So I'm going to copy the configuration and copy the examples and root web apps. So I start with demo, which is the base Graal. The base Tomcat native is the same, I just copied it over. So I have demo files, which is bin, for example. It has Tomcat native, and that's it. So conf, I have my regular configuration files from Tomcat. As I said, for example, this one is the default one, mostly, except for some kind of differences. Like for example, there's -2 here since it's Tomcat embedded. I don't need a shutdown port. Also, I removed some base listeners, which was the memory leak, whatever, on the JMX1 and things like that. So, otherwise, it's really the base stuff. All right, so now I'm not going to copy this that way. Okay, so I'm copying that. All right, paste here. All right, in web apps, I have the base Tomcat web apps. Yeah, in conf, I think, yeah, there's one difference here. I'm going to mention it. I added a wrapper listener for load on startup, just for convenience for me. I'm going to explain why. And also, that's done automatically for Graal, but I left it there to be more obvious. With Graal, you need to delegate the class loading. What it means, basically, normal Tomcat, it tries to load classes from the web app class loader first. Since it's Graal, actually, the web app class loader, it won't be able to load anything because it will be dynamic. So instead of loading stuff, the web app class loader will instead delegate to the parent class loader, which is the fat jar, basically, compiled into native, which will instead load all of its classes. That's a very important distinction, because while the web app class loader will not load anything, you still need to have your classes inside your web app for stuff like annotation scanning and things like that to still work. So that's why your web apps still don't need to change. It needs to stay intact the way it is. It's a bit of a hack to make annotation scanning works, but it works very well this way. So we are going to start the process for the examples web app. So we have dependencies on JSTL. We are going to add it in the main POM. Sorry. Okay, so that's what we have. I'm going to add that here. Yeah, I'm going to start compiling instead first, but just after that I'll start again. All right. So I'm going to add JSTL here. All right, done. All right, so I'm going to set a few properties here. Right. So I'm switching to my demo work folder. I will build the main Tomcat jar for dependency stuff, like whatever. right? It's including, so it has now built a fat jar with the word Tomcat. Basically, it's here, it's in target, yeah. All right. So it has an 8 something megabytes with fat jar with the entire Tomcat. All right. So after that, I'm going to precompile basically. So I'm precompiling the examples web app. Alright, so it's just normal JSP precompilation. It took about 1 second. It's multi-threaded now, so it's fast. Yeah, because it has quite a lot of jars. So, okay, for fun, I'm going to show the root web app, which is a bit special because of the expression language use. I'm going to talk about it a bit later. So it has one JSP only, if you remember. It's only index.jsp, so it's pretty fast. All right. So I can copy the load on startup listener. Okay. In my file, I have a load on startup wrapper listener. Basically, all it does is set load on startup on all the servlets, and the idea is that basically, if I load all the servlets during the tracing with the substrate JVM, I won't have to declare them manually or exercise all the paths. It has limits because the only thing it will do is load dynamically all the servlet classes. So if you have, like, for example, WebSockets or whatever, it won't be enough. So it depends on your web app. So that's a kind of like a load on startup is a trick you can do to avoid having to have a big script that does a lot of requests on your web app, you know. So that's why I'm using it here. It's not very magical or fancy or whatever. So I'm going to copy it into demo, into source main Java util. Alright. Okay, so all you see here now in the main Java is all the sources from the examples web app which were copied by my packaging, in addition to all the JSPs that were compiled into servlets. For example, we have examples of Apache JSP, whatever, async, whatever. We have here a precompiled JSP, a normal one. Alright, next. Okay, the next step now, I'm going to run here. Okay, so as you can see, everything was okay now. We need to rebuild, I think. Let's see. Yes, we need to rebuild the fat jar with the entire thing, including all the web app classes now. So it's compiling all the servlets now and re-including the Tomcat dependencies and things into the fat jar. So the jar basically got a bit bigger now. See, it went up by a few 100 kilobytes. All right. So that's all right. So now we have a fat jar with the entire Tomcat plus examples. Okay, so now we are going to do the reflection setup. Alright, we need to generate descriptors for the web apps, which means we are going to start the substrate JVM of Graal with a tracing agent. It's very easy. Basically, all it needs is a command line argument, so I'm going to show it. And then we are going to access JSP, WebSockets, whatever, that we want to use, that are present in our web app and that users will want to use. Or, if it's enough, you can just load on startup servlets, depending on what your web app does or what kind of class loading your servlets are doing. It could be enough. It's up to you to test, really. Alright, so let's run the substrate JVM now. So I'm going to export my Graal path. Okay, in my demo, there's something a bit weird, that I have 2 Graal paths. It's because 2 weeks ago, there was an update of my Linux, which basically broke the Graal native image, and I had to build a Graal from Git, basically. So I built my own JVM to have it work. Yay! But for the native image agent, I'm just using the base Graal since it works. Not that crazy. So, all right. So basically the command line here is that I'm going to put it in the terminal actually, it's going to be nice.
Give the
All right.
sign first.
What?
Oh no, it's okay.
Yeah, basically, okay, I define the Java home as Graal, so I'm going to run that JVM, and that's the native image agent that will generate all the traps. It will put it in trace file or JSON. I can show what it looks like. It's pretty nasty. And so I'm going to run my target Tomcat Maven 10 jar, which is my fat jar with everything. All right, let's do it. Alright, so it's starting, no problem. It takes forever, no problem. Alright. Okay, so I'm going to exercise some paths now, for example, to see that it's working. It's better to test. Alright, I'm going to put it here. Alright, let's do that. Yeah, it's working. Alright, cool. So nice. Alright, let's go. Going to load stuff just to see if it works. Alright. That's because I'm using a self-signed certificate, so don't worry. I put it actually some tracing here, so I have fine logging for HTTP2, just to show that HTTP2 will work actually. Because it's using Tomcat native. If you remember, I copied Tomcat native, it's in the bin folder. So I'm not going to access many JSPs or whatever, only WebSockets. Why? Because I have my load-on startup for servlets and stuff, but WebSockets or endpoints aren't load-on startup servlets, and so I need to access them manually to have them work later. So I'll connect, alright, disconnect, alright, whatever. So I have my chat example, whatever. Oh no, that's a multiplayer snake, that's the one I wanted, alright. Okay, so I will try the multiplayer draw board, and just for an interesting example, you see a failure basically. So there it works, no problem. That's the substrate JVM, everything works. That's a good thing. So then when I'm done, I'm just killing it. So it's fine. All right.
Okay. I have a question.
Yes.
So this was still a regular JVM?
The substrate, no, it's the Graal substrate JVM. It's some weird JVM built very custom and very funny.
But it wasn't native, right?
No, it's behaving like a regular Java 8 JVM basically.
Right.
But it's a very funny JVM actually underneath. If you really look.
So this is the test before you go.
It's not the test. It's a needed. Basically, all you're going to do anyway is use that substrate JVM, because native image is actually using heavily the substrate JVM. So it's really a component of Graal. But you won't have problems with the substrate JVM basically. You don't need to care about it that much.
Yeah, it has two modes. One is hotspot mode,
Right.
Traditional.
Right, but the
JVM.
fancy mode will come next.
Yeah, the
Yeah,
other
the
one.
fancy one. Okay.
That's
so
what I want to
okay.
show.
Yeah.
Okay.
I'm going
Right.
to show quickly like. Okay, I have my trace file. Okay, so that's what was generated by the agent. Still loading.
Okay, as long as you don't have to type it in, it's okay.
Yeah, basically that's why you don't want to type that.
In a live demo.
So then we have a kind of utility, because, okay, the funny part is that Graal doesn't use that trace file. That would be too easy. You have to parse it and generate other files with that native image configure thing. So that's what I'm going to do. So I'm using native image configure and generating the trace files in that output directory, whatever, still the same basically. So that's it, done. So now I have a lot more files with the resource configs and so on. Yeah, I have a lot of. No, that's resource. All right. I wanted reflect config, which is basically the thing that was generated. As you can see, you have all the examples JSP servlets which were precompiled. You have all of them declared in the descriptors. That's really what you want. You have also like some WebSocket endpoint. I saw some anyway. So also based on Tomcat classes, for example, you have standard server, all that kind of things. That's why those based Tomcat classes aren't in the base Tomcat descriptors that I provided. There's only the base interfaces, and not everything, because most things will still be detected and things by by the tracing agent. Alright, so we are there. Alright, so we did that part. Alright, so that's where you need to manual configuration for missing items. So as I said, resource bundles, they are loaded with get resources as string usually, and they are not detected unfortunately, so we have to add them manually. Also, the expression language, it uses bin info reflection, it needs manual reflection setup, and also base interfaces. So we're going to try that later. Alright. So what do we have? For example, we are going to add the resource bundle. For example, web apps, it uses a resource bundle in the main folder, in the main package. So we are going to add that. Okay, so we have that here. No. Okay, I'm not going to put it here. I'm just going to put it in the main. Right, in the main file. Okay, so I'm going to add it here. Okay, and so just like the other bundles, my example bundle will be loaded. Alright, what do I have other than that? I think I have, yeah, okay, I'll give a bin info example. For example, in the expression language, in the main index.jsp, we have an expression like that. It does page context, .servlet context, .server info. You can understand pretty easily what it does. It gets the JSP page context, the servlet context property from that page context, and then you know it does get server info. Okay, since it's using bin info reflection, it's not detected manually. You need to add that kind of stuff to have it work. Basically, the core page context class and the application context, which is the implementation of servlet context in Tomcat. So I'm going to add that in the reflection JSON also. And that's where basically you run into most errors. You'll find stuff that needs to be declared that wasn't detected, and that's kind of annoying, but yeah, has to be done at the moment. So I'm going to put it into the reflect config, whatever, just right here, in a random spot, it's alright. Yeah, alright, should be okay. So I did page context and application context here. And at this point, we can go into the native image generation. So here, I'm switching to a custom built Substrate JVM and native image, because the regular one won't work on my Linux. Eventually, you'll get a new Graal build, and it will work without having to build your own Graal. If you have an old Linux also, or a not up-to-date one, it will work out of the box. It's cool. I wasn't happy like 2 weeks ago already. So you're going to run native image. Okay, many errors can occur here. Most likely it will say like, oh, I don't like it because you have some reflection thing going on. Oh, I don't like it because you have a static initializer. For example, in Tomcat, we still have a static initializer causing problems, so I'm not using it anymore. Like in Julie, for example, in static initializer, when static initializer is starting a thread, you can't do that basically. I'm not sure why, but you can't do that. Graal will complain and tell you to get lost basically. And so you have to fix your static initializer in a Graal compatible way, which is usually basically not doing stuff in a static initializer. It's not a good idea anyway, so. Yeah, that's where you get beaten basically, because all the good practices you heard about before, we find that way now.
Are the error messages useful in finding?
Mostly. Okay, so I'm going to hurry up. So native image generation, alright, let's go. Yeah. So you have this big command line, basically. Okay, it has a lot of options. Like enable HTTPS is useful. Initialize at runtime, you load a few classes at build time to do stuff like static initialization. Actually, it doesn't work in all cases. That's to add support for GNI, for Tomcat native. We report unsupported elements because otherwise it will break even more often. That's good. It doesn't help. Enable protocols because by default it doesn't have HTTPS either or URLs. Tomcat needs them. Configuration file directories, that's for the descriptors we had. Reflection configuration files, yeah, that's for the base reflection configuration file we had. The resource is the same for the resource bundles, basically. So GNI, we have a bit of configuration for Tomcat native, and that's about it. And basically, that's the main factor we are compiling into native image, and so it gets into that process, which takes some time, but not too long. So basically, if you get there already without errors, you're good. Like, you're very good. Okay. So at this point, you may find out that some libraries are incompatible. You need to bug the library author to make a Graal compatible version, or use a framework which replaces the code in that library to make it compatible. You may have some of your code which may need to be fixed for whatever reason, just like I did for Tomcat. When it fails, you need to go back to step 3 after fixing everything.
Which one is step 3?
Step 3 is where you trace your stuff for reflection and things. It's the base step. So, yeah, it's pretty frustrating. So after that, you're going to test your native image. That's very cool. So you're going to run the executables, and at this point, obviously, many things can crash and burn and whatever. And you need to go to step 3 when it fails. I didn't say if it fails, it will fail. So, as you can see, it built it, didn't take that long, so that's okay. I still have a few minutes, so I'm fine. So I'm going to run that, yay! I'm going to show it. As you can see, I have an executable. It's 53 megabytes something. But it has the whole Tomcat, basically, and the examples. So I'm going to run it now. Alright. I have a library path here. Okay, that's for some stuff which I'll talk about if I have some time. There's some libraries from Graal which aren't dynamically loaded.
So that's for native libraries?
Yeah, and that's where it started Tomcat. I said it's just fully started right now. You can see it start, right?
What's the difference? How long? 4 milliseconds?
That's pretty much it, yeah. So as you can see, the main server initialization is 15 milliseconds.
Very nice.
And the web apps, it's a bit the same. So I'm going to show the difference later. Okay, so I'm going to access some apps now, because now there's run executable test. Then I go to a container thing. Okay, so I'm going to test it again. So let's try it. Okay, I put refresh here. Okay, as you can see, it's still using HTTP 2, no problem. Going to run the WebSocket thing. Oh, as you can see, I went straight to the things that failed. But because the drawboard, for example, why did it fail? All right, you can see the exceptions. Not very, very fun. Oh. That's where it closed. Yeah, no, it closed the WebSocket, the HTTP 2 connection at this point. Okay, why did it fail?
Not
Because
just now?
Java AWT problem, it fails. Why? Because it's not implemented. It's very easy. You search it on Google, it will say, oh, we didn't implement it, sorry. So that's what you'll get quite often, but AWT, which is a graphics API, is not implemented. It's not very surprising when you think about it, but yeah. Other than that, you get the regular snake, it works. No problem. With HTTP 2, no problem. Through Tomcat native. So that's pretty good already. So I'm going to shut it down now. And in a container, okay, we're basically going to generate a container image out of that native image. So building the container image, okay, the base image now doesn't need Java, right? It's a standalone native image, so we can drop that thing. And I found out that BasicBox was better. So whatever, I had to remove Joroka and Prometheus. So by default, at least Prometheus is using JMX, so it's not working. So we need to use a different Prometheus exporter and compatible one, but I don't have one. So I skipped that. All right.
So what's the image for BusyBox?
Yeah, it's using BusyBox. You can have a look
That's
at
the name of the image. That's the full name.
Yeah. Okay. So what I'm going to do right now. So I'm going to build the native image again. Why am I going to build it again? Because I'm adding static here. Static means I want Graal to statically build libc and zlib inside of the native image, so that it can run on a bare bones base image.
So it's like a fat bin, like fat jar. Fat
Yeah, exactly. Because otherwise I would have to run my container on the same target platform that I'm using here. There are problems at this point because TLS is a big issue. Graal doesn't have the capability to statically compile additional libraries, so it won't statically compile Tomcat native. That means basically you won't get any TLS support here or HTTP2 at this point until that's implemented. Also, you won't get TLS through JSSC since unfortunately it uses elliptic curve support, which is a separate shared library. It won't be compiled into that file binary. So only the basic non-encrypted will work at this point. Oh, I wanted to show a comparison with regular Tomcat, but I'm going to show it in the container. It's very easy that way. So basically, I'm going to build two container images, one a regular one with my normal Tomcat native Docker file, and the other one with my Graal Docker file. Yeah, I still have 3 minutes, all right. Okay, so now let's look at root. All right. So I'm going to build my Docker, my images now. So the regular one. I won't have time for the OpenShift demo, but it's a bit the same. It's deploying those images to OpenShift, so it doesn't make that much difference.
It's confusing sometimes because we use the same term for different things. I mean, container in the Tomcat realm, it's servlet container. Here it's a Docker container.
Yeah, it's not my fault.
So it's not enough to say container. You need to say Docker container.
Yeah, the Docker container, right?
It's an exception of the containers, you know.
Yeah, it's still a container. Yeah. So here I'm building the Docker container with a native image. Okay, I'm going to have a look at that thing in my cockpit. All right. Okay, Docker containers. Yeah, so I have one, the regular one. All right, that I'm going to start. Run. Yay. Run it. So it takes a while to start up. All right. Then I'm going to start the Graal one, which is probably okay now, by now. Right, yay! Then we are going to have a look at how it works. Alright, you can see a little bit of difference in the memory use, right? You can see it or not? Going to increase the size, alright. So the first one, like the regular one, is using 400 megabytes, and the native one is using 34 megabytes, so that's less. Alright, you can see the startup time. Basically, the deployment of web apps takes milliseconds. Example, oh, by the way, I forgot I didn't remove my load on startup servlet, so the normal setup starts faster. Actually, you don't need load on startup anymore, obviously, but I left it in. You have an error here. As you can see, that's because Tomcat native isn't there. That's because it doesn't support shared libraries. And another error here about the Sunny C, which isn't getting loaded. So I'm going to show that you can access it. You have the IP address here. All right. And that's the native image. So the unfortunate problem is that you don't have the TLS support. So I wanted to show OpenShift support. It works great as well. The only problem is that since we don't have TLS support, and in JSON TLS support with the elliptic curve missing, you can't even connect to the OpenShift REST API, and that's a big problem. because you can't get a pod list or do any operations from within the container. So I'm talking about it here. Basically, you have SunEC, which is needed for TLS, JSSC, and it's broken. And the static linking the static linking of Graal is lacking at the moment. So at the moment, you have to build your containers on your target platforms, which is kind of very limiting since you can't have minimal images anymore. So you can track the issue here. Okay, so yeah, for packaging, test using Docker first. All right, I have a deploying to cloud, but I don't have time for that anymore. But yeah, basically it's the same. You deploy to your Kubernetes and you test it there. Basically, if it works in Docker, it will most likely work in your Kubernetes environment. So at this point, you're good. All right, so I could show you have a huge startup and memory use benefit. Since it gets down to tens of milliseconds, you can have on-demand services based on Tomcat. If you allow a little bit of initial performance penalty on first request, it's not too bad. I mean, it's only tens of milliseconds, so it should be alright for small web apps. Obviously, small container image, and it still looks like a normal Tomcat. You get your own configuration files as usual. Your web apps are mostly the same, and all sorts of things. Obviously, you need, however, lots of work for setup. You need a process automated with a tracing agent. You could have many libraries which are incompatible. TLS is a big problem at the moment. I hope it will get fixed. It will hopefully be better once they implement Java 11. It will have ALPN support in JSSC. You lose some useful features which I love, like JMX. I love my JMX and they took it away. I'm so sad. I've been using it since 2000 basically, so oh well. And I found out if you have high load, like a really benchmark, like you're hitting your server really bad, you won't get much performance benefit actually. It won't run any faster than Hotspot. Hotspot is really good at optimizing your code after a while, so basically the performance is not going to get any better. The thing is that it's really for small container images and on demand.
Serverless.
Serverless, yeah, that's the key, that's the hype thing for
AWS Lambda.
Yeah, and I'm done.
Let me have a question?
Yeah.
So what happens if the application in the container needs more memory? Does memory management just like a JVM, or what happens there?
Oh, it's managed by the container platform.
But would memory ever be released back to the node, or never? It only grows.
Yeah.
Okay.
Yeah, I'm pretty sure it only grows. But the thing is that it doesn't grow any bigger than your JVM with heap, so
Right.
it's very similar. Like for high load, I noticed, like, you know, when you're hitting your server, like I did, for example, a CP2 benchmark, and in the end it's using as much memory as Hotspot. So, and it's having the same performance more or less. You have I'm saying that with some amount of caution because I didn't test with the Enterprise Edition of Graal, which is supposed to be better at that. So I'm going to try to investigate with Enterprise Edition at some point. Any other question?
What's it like to debug?
Okay, debugging when it crashes. Yeah, that's harder. That's very hard. Basically, it's when it's really the last step of productization. So you need to then enable debug logging whenever possible. Yeah, figure it out from there. Some crashes are really like seg faults, so you have to investigate the cordon. Good luck. Some crashes are more like regular Java problems. It doesn't do seg fault and problems. Basically, we run into seg fault, for example, with some GNI stuff, like interactions with Tomcat native. Like we had that when we tried to run the APR connector, which we kind of weren't able to make work. So that kind of issues, like you get into big nasty seg faults without any really useful information. So That's pretty bad. But if you're just staying in Java carefully, you probably won't get too bad on that front. All right? Yeah?
Do you see any tooling on the Tomcat side that you could develop that would help the process of generating the...
Well, I actually did a lot with the Tomcat native packaging. Like, all you get in Tomcat native is really, really useful, and I don't think you need to get that you need that much. It's a process, and I don't think I can automate it further because you need to exercise your web app in a proper way. It's really web app dependent. Now, what you have here is pretty good because you have the base stuff you can't generate yourself. That's here. You would have to do it manually. It's quite annoying. You have Tomcat, the code of Tomcat, which is now Graal compatible. Basically, treat Graal as another JVM. Like we have